of H plus ions, and the bicarbonate ion is more increasing. And the fourth step will be the H plus ions, the concentration. If the more concentration of H plus ion is there, it will bind to the actual carbonate in the seawater. So that finally, the CO3 carbonate ion molecules is depleting, whereas the bicarbonate ion is increasing. So here, there is two possibility of chemical reactions. So one is the H plus ion increasing makes the acidity of the water, and the second process is the depletion of carbonate ion. This carbonate ion is very useful to the biogenic organisms for the taking the calcite and the aragonite type of calcium carbonate in the molecules in the animals. So, glimpses of the ocean acidification process up to the current scenario. And in the pre-industrialization era, the carbon dioxide was 280 ppm, but today it is reached up to the 410 ppm. pH from 8.3 is now reduced into 8.15. And in future, the IPCC predicted that the ocean pH is going below 7.8. So this is the year-end scenario predicted by IPCC. So based on the prediction, we have unlike. இந்த ஆளை கிளிக் பண்ணிட்டு
என்னமோ ப்ளூ இங்க் வருது. ப்ளூ வந்தா என்ன?
இங்க
Please unmute to Deva Roja. Rangesh, please open your mic. Rangesh, please open your.
And the Indian Ocean, when we compare among the ocean, global ocean, compared to the Pacific and Atlantic Ocean, Indian Ocean showed the pH level coming near the 8.1. So this is the effect. We have evidence that the Indian Ocean is also threatened by ocean acidification phenomena. When we compare to the many studies, we have find the gaps for my research topic and given the rationale of the research. So when you compare the Gulf of Mannar Biosphere Reserve region, which is known for its richest biodiversity of coral reefs and other keystone species like echinoderms, mollusks, and other kind of species. So there is a complete lack of knowledge on the calcite saturation state in the seawater, and also the complete lack of knowledge in the microcosm experiments in the Indian Ocean. So the rapid extension of religious tourism and the aqua farming in the Gulf of Mannar region has more prone to the serious threat to the increased CO2 emission, and it may be a hypothesis that the more ocean acidification phenomena may happen. And the hypothesis one was made for the calcite saturation state in the Gulf of Mannar, which will vary across the different seasons and stations, and will show the significant changes for as per the spatio-temporal dynamics. So this is our hypothesis one. The hypothesis two was made for the hypercapnia microcosmic environment, because the microcosm experiment, the maintenance of pH in the lab, is not a simple process. It's a challenging one. And we have to set the pH levels, different scenarios. We have set for the exposure of organisms. And hypothesis 3 was made for the microcosmic hypercapnia condition to sea urchin and the Salmacis verticillata based on the effects, biological effects like biomineralization, biomarkers, and reproduction. So based on our hypothesis, our objective was made. The objective one was to study the spatio-temporal dynamics of calcite saturation state in the Gulf of Mannar waters. And the second objective is to standardize the microcosmic hypercapnia exposure in our Pudumadam research lab stations. And third hypothesis, to expose the animals. And these animals will be assessed by the biomineralization. Biomarkers is the fourth objective, and the fifth objective is the analyzing the tissue damage according to the different pH treatments, including with the control. So coming to the materials and methods, we have followed the two approaches for these 5 chapterizations. So the approach 1 is the wild seawater collection and assessment of physicochemical parameters, and the approach 2 is the assessment of biological effects using the laboratory-based hypercapnia microcosm experiment using the CO2 gas bubbling method, which is one accepted method by a global standardized ocean acidification protocols. So the research design was made based on the selection of study area. We have selected the study area in the islands, the 3 islands of the Mandapam group of islands, and we have collected the animals for the second approach, that is the hypercapnia exposure condition in our laboratory-based microcosm experiment. So the Salmacis burugulata is the sea urchin found in the Gulf of Mannar, and the Guneo scabber is also found in the Gulf of Mannar waters, which was the selected echinoderms for our microcosmic hypercapnia exposure. And for the approach 1, the spatio-temporal dynamics of calcite saturation state. Actually, we have selected these 3 islands from the Gulf of Mannar region, and we have gone for the monthly sea voyage for a sampling of water samples. We have collected the water samples in the 3 different island area for monthly sampling for continuously 1 year, and we have extended it into the 2 years. So totally 2 years of seawater coordinate data we have analyzed. So actually, for onboard measurement of seawater coordinate chemistry, we have measured the pH, temperature, salinity, and total alkalinity using the following kits given in the slides. So after the onboard, we are cross-checking these parameters with a high accuracy when come to the lab, and we have made the titrimetric evaluation of the seawater coordinate system for 1 year. So totally we have sampled 288 numbers of data, water physicochemical data. And when we taking the coordinate inputs, so the inputs are pH, salinity, temperature, and total alkalinity. When we given into the US-based software that is called Seawood Calc, when we enter the software, we have obtained the results. The results include the partial pressure of carbon dioxide, total carbon dioxide, and the fugacity of carbon dioxide, and the bicarbonate ions, carbonate ions, and the total CO2, and the boron alkalinity, OH concentration, and the Ravalli factor, which is the important factor for ocean acidification research, because the Ravalli factor determines the water quality. So how much of the ratio that atmospheric CO2 absorb into the ocean, that is the Ravalli factor. So the atmospheric CO2 which dissolve into the dissolved inorganic carbon, that is the Ravalli factor. And based on that, we have measured the calcite saturation state. So our ultimate goal is to study about the calcite saturation state in the Gulf of Mannar waters, to study about the health of the marine ecosystem, particularly our selected echinoderms. So for the second approach for lab-based microcosmic hypercapnia exposure, we have followed the best practices for ocean acidification research published by European Commission for the research methodology. So we have collected the animals from the study areas by the scuba diving and the snorkeling in the depth about 5 meters. And with the help of that, the animals were immediately brought to the lab and acclimatized for 7 days. Here I have to tell what is acclimation and acclimatization. The acclimation refers to bringing the animal into the new environment. But in contrast to acclimatization, the animals bring to the new condition. So new conditions like new pH or new temperature or new other physical chemical parameters. So after acclimation and acclimatization over for the 7 days, so we have exposed the animals for 14 days of different pH levels. So the pH level 8.2, you can see the first pH levels. So we have collected the filtered seawater. The water source is from the nearby coastal region, and we have filtered the seawater and make it into the for the microcosmic hypercapnia exposure, and we have selected the method called a static renewal experiment. When we go to the flow-through experiment, the pH level was difficult to maintain. So the static renewal experiment, we have maintained the pH levels in day-night basis, and we have checked the every parameters for 4 hours in the laboratory conditions. So using the following instruments like pH ionometer, hand refractometer, and the volumetric filtration for total alkalinity, and remaining associated coordinate parameters using the Seawood Calc software. And after the end of 14 days microcosm hypercapnia exposure, we have collected the animal samples for tissue. During the hypercapnia exposure, we have collected the 1 to 2 ml of hemolymph pH of Salmacis brugulata and Goniodis castor scaber was extracted using syringe needle, and we have measured the hemolymph pH. So here that we can measure the oxidative stress, how much pH is varying, and we also collected the tissue samples. So like biological samples from spines and test exoskeletons for the biomineralization assays. We have collected the digestive tissues for the biomarker enzyme assays, and we have collected the female gonad tissues for histopathology studies. So for the biomineralization assay, we have used different biophysical instrumentations for measuring the exoskeleton biomineral properties. Either we have tested the robustness of the biominerals using the thermogrametric analysis, Fourier transform infrared spectroscopy, X-ray diffraction analysis, and the scanning electron microscopy analysis. After that, the digestive tissues were subjected to the different biomarker assays. So the biomarker enzymes we have chosen was acetylcholinesterase based on the Elman et al. 1961, catalase based on Sinha et al. 1972, Habik et al. Based on glutathione transferase based on Habik et al. 1974, and lipid peroxidase based on Okawa et al. 1979, and reduced glutathione based on Moron et al. 1979. We have collected the triplicate samples, and we have measured the spectroscopic variations based on the methodology as per the standardized methodology. And finally, we have collected the tissue samples from the gonad tissues. So the female gonad tissues of sea urchin and sea star, we have dissected out and histology staining. And for that process, we have taken as the automated tissue processing units, and we have tested it based on the protocols as per the Lang et al. 2006. So after that, the two approaches, the spatiotemporal dynamics data and the laboratory-based microcosmic exposure data, was studied with the data analysis, extensive data analysis like statistical software SPSS 21, and we have specially made the structural equation modeling using the path analysis in the SPSS AMOS software. So this AMOS software gives the structural equation modeling for our spatiotemporal data. So we actually planned do the multivariate analysis, but the SPSS AMOS was advanced level for the multivariate analysis, which is showing the structural equation modeling of the spatiotemporal dynamics. So which factor affect the calcite saturation state. So descriptive statistics were used for the microcosmic exposure for the 4 different pH scenarios. And the bar chart used for biomarker enzyme assays using the Excel 2010. And single factor 1 by ANOVA was used for the identify the significance of changes observed in the quantitative biomarker analysis. And the results of FTIR, X-ray diffraction, thermogrametric analysis has been plotted in the Origin 8.1 Pro professional software. Coming to the results, so the results, the spatiotemporal dynamics of pH and temperature in the Gulf of Mannar are given here, and we can see the 3 different spatials. So 3 different stations we have measured so far, 2 years of data. So we find out the pH levels in the post-monsoon season. We have obtained the very lowest pH, And in the summer season, we have obtained the very highest pH, ranged from 7.86 to 8.55. So I can ask why the pH varies from the minimum and maximum values, but the mean pH, which shows 8.2, it is the ambient scenario we have measured for our hypercapnic experiments as the control. So based on the Armugam et al. In a study in the Gulf of Mannar waters, also have the reports that 8.2 is the average pH in the yearly annual samples. So, but we have to taken care of the minimum pH, that is 7.86 in the region, which is supposed to happen in the winter season. And the salinity value, temperature value is also highest in the monsoon season and the post-monsoon season. When we compare the salinity, so the highest salinity is found in the monsoon and the post-monsoon season. When we compare to the winter and summer, so the middle of the winter, we have a highest salinity going to the 35 levels. So when compared to the total alkalinity, so the lowest total alkalinity was found in the monsoon season, and the highest total alkalinity was found in the post-monsoon season. So we actually compare the PCO2 and FCO2 data, the same kind of varying patterns found between the PCO2 and fugacity of carbon dioxide. So both are measured as atmospheric CO2 level, but it is highest in the post-monsoon season, which can obtain after the rainy season. The more CO2 comes to the ocean. So as based on the TCO2, the total carbon dioxide is also give the strong evidence for the FCO2 and PCO2 data for the same kind of patterns. And when we measure the bicarbonate ions, so the bicarbonate ion is also highest in the post-monsoon season and also in the summer seasons. So when we compare the carbonate and boron alkalinity, they have a different patterns, and the highest pattern is found in the monsoon season. So this is the reason when the precipitation happens, like heavy raining or intake of river waters coming to the ocean in the Gulf of Mannar waters. So there are many minerals coming to the ocean. So that is why the carbonate ion is highest in the month of monsoon season. When I compare to the calcite saturation state, so which is the ultimate aim of our study. So the calcite saturation state is the indicator of the health of the marine ecosystem for echinoderms. So we actually found that highest calcite saturation is found in the monsoon and post-monsoon season, whereas lowest calcite saturation is found in winter season. So the calcite saturation state is varied from 1.68 to 6.85. Here we have a doubt that lowest calcite value is 1.68, but the highest is 6.85. But the 1.5. So is it adequate or minimum or maximum? So there is interpretation from the previous reports from the reports from the Gattuso et al. 1998 and Farfan et al. 2008 in the recent literature. They have suggested that the values supersaturation of calcium carbonate levels. They categorized this into the extreme low and marginal, adequate, and the optimal. So our average pH is 3.41 calcite saturation levels. So in Gulf of Mannar, there is adequate levels are found. But compared to the winter seasons, it is going to the low concentration of calcite levels. So here we have cross-checked with the one-way analysis the variations of different physicochemical parameters in the spatio-temporal aspects, say like seasons, station, time, and depth. When we compare the depth, apart from the time, stations, and seasons, the depth did not significantly vary in the Gulf of Mannar waters. So because the Gulf of Mannar water actually have the 5-meter depth, so the waters did not significantly vary. The calcite saturation state also did not vary with the depth. But in the case of seasons, all factors are significantly varied. So all factors were varied with the stations, time, and seasons. So when we compare with the other parameters with the calcite, with the correlation for physicochemical parameters, we have found the highest calcite with the pH. So the 0.813, which is the highest strong correlation, and the other one is carbonate ion. So the calcite has a more correlated with the pH, and the carbonate is our results. And when we see the structural equation modeling, when we do the multivariate analysis, which is the advanced multivariate analysis, this is the path analysis. So the path analysis shows that the calcite levels with the pH, salinity, and temperature. So the pH, you can see the 6.31 covariance. This arrow indicates the covariance. So these covariance indicate the level of pH changes based on the different conditions of environment. If we say the interpretation of the variations found among the parameters, the 6.31, if the pH increase or decrease, one pH decrease, the 6.31 level of calcite will be changing. So this is our research suggested that. And when we compare with the calcite with the total alkalinity coordinate and bicarbonate, we can't see the significant covariant found in the results. So, and compare with the PCO2 and FCO2 as well as total CO2, we cannot find that much level of differentiation compared to the pH levels. And we have, when we compare to the spatiotemporal dynamics in the structural equation modeling, so the seasons have more influence on calcite rather than stations and depth. Here, the time is also influencing. The morning time and the evening time also suggesting that the influence of calcite level variation. And when we compare the overall parameters, physicochemical parameters, we can say 0.25 level of covariance found in the pH levels. So this also suggests that pH and carbonate is the most influencing factor for the calcite saturation state. When we compare the experimental setup with the 4 different parameters, so that we have monitored the pH, temperature, salinity, and total alkalinity with the associated coordinate parameters. So in both cases, when we compare with the parameters with the nominal pH as well as effective pH. So the nominal pH for 8.2, 8.0, 7.8, and 7.6. So we have maintained the same level of pH in our laboratory microcosm. So the total sample number was 84 in our 14 days of experiments. And when we compare to the microcosm experiment of Goniodiscaster scaber, the same kind of pH level was maintained at this levels. And when we see the mortality rate of hemolymph pH, so the mortality rate, and there is no correlation with the mortality rate and hemolymph pH, but there was no mortality in our study. So because in our trial experiment and the previous studies carried out by our senior scholar, there was no mortality up to the pH 7, but the stress is happening below pH 7. The mortality was occurred during my seniors studies in the same region, and the hemolymph of pH shows the high level effects found between the Goniodiscaster scaber and Salmacis virgulata. So when we compare with the biomineralization aspect studies, we can found the signature of the calcite structure. We can't find out the calcite structure in several instrumentation, but the only some kind of instrumentation we can found the calcite biominerals, because it is difficult to identify. Why? Because calcite, aragonite, vetirate, these three are the calcium carbonate minerals. These are the biominerals which is helpful to the structure their own body shell making of shelled organism, but due to the small changes in the mineral structure, it is difficult to identify. But we have the signature patterns based on the studies carried out by the previous reports. When we compare that 713 is the exact calcite levels in the animal exoskeleton of shelled organisms. But when we compare the other treatments, when we compare the treatments with the control, the control samples have the good signature of the 713 peak, and compared to the other result, it going to 715 and 717. And the peak of OH bond, single bond OH, influence the pH levels, which is also varying from the control and treatment pH. So when we after the FTA or analysis, it gives a signature idea. And when we compare the X-ray diffraction analysis, the biominerals are showing the short peak value, but this is not a case to explain the structural variation. So these peaks enunciate the arrangement of atoms in the animal tissues, exoskeletons. So to rightly say, the both sea urchin and the sea star has used some of the peaks, which is called as HKL values 104. The plane of arrangements of the structure of calcite is missing in the 7.6 and 7.8 exposed pH. So further, when we compare our biomineralization studies with the thermogravimetric analysis, we find out the different steps of thermal loss, find out in 5 steps. So the water loss steps and the microcalcium carbonate dissociation and the water molecules have evaporated, and the phase transformation phase from the amorphous calcium carbonate to the calcite and the complete volatilization. These 5 steps happened during the 5 steps in the exposed and treated control animals. So eventually in higher pH, in higher temperature, the pH 7.6 shows a higher range of weight loss compared to other pH levels, including the control. So the 7.6 and 7.8 pH also have the highest weight loss, which happens and which makes the calcium carbonate shell exoskeleton more fragile in the organisms. When we compare in the morphology analysis using the scanning electron microscopy of sea urchin, when we compare the sea urchin in the shells, so the to rightly say it is called as test in case of sea urchin, and it is rightly to say ossicle and spines in case of sea star. This is a sea urchin test. Bottom surface spine. There have a large scale of pores in the low pH treated samples, and we can find out the measurement of the number of pores found between the control and treated animals, and there is a dent, and the corrosion and the fragileness is showed in the pH 7.6 exposed animals. Compared to sea urchin, the Goniodiscastus scaber is also facing the similar effects. Here, the miniature spines break down into the very large scale in the pH 7.6 treated animals. So here is the study enunciate that the biomineralization is affecting the pH 7.6 and 7.8 levels. So coming to the biomarker results. So the biomarker, the total protein, we can see the total protein varies from 0.3 to 0.09. So is the molecular building block of the organism. The protein level varies in the.
Please mute Ms. Devaraja.
And the pH 7.6 levels, the treatment, the high level of variations.
Devaraja, please mute yourself.
So, according to the biomarker enzymes like acetylcholine esterase, catalase, glutathione transferase, lipid peroxidation, and reduced glutathione, which has highest variations between the control and low pH exposed samples. So when we compare the acetylcholinesterase, the low concentration of acetylcholinesterase found in the pH 7.6 exposed to animals. So the animals exposed to 7.6 have the more number of accumulation of neurotransmitter without the right concentration of acetylcholinesterase. So the acetylcholinesterase concentration is depleted in the pH 7.6. Compared to the catalase is also depleted. The catalase is the indication of compact with the compete with the protect from reactive oxygen species. So the catalase concentration is also reducing compared with the glutathione transferase, which is increasing, which shows that the organism have the high level of toxic or pollutant response by the organisms. And when we compare the malondialdehyde concentration, so the malondialdehyde is the lipid peroxidation of the organism's membrane. So the lipid peroxidation is the process of degradation of lipid membranes. So the this lipid membrane damage is showing with our study. We have the strong evidence with our histopathology studies. So I will show that all different kind of biomarker enzyme is varying significant in also with the C-star, Brunner discussed scabber. Coming to the histology sectioning, the gonad tissues of Salmacis brugulata, which shows the histology sections, which shows the mature ovaries. So the mature ovaries in the sea urchins, in the female gonad sea urchins, have showed the vitellogenic oocytes with the has a very disruption of density of X cells in the 7.6 exposed pH. But compared to the other pH, the lesions are less found, and the control has an intact cell. There is no lesions found in the control. And when we see the 7.6 pH, the lesions are high occurring, and the globules of accessory cells also have the destruction of cell envelope. And coming to the histology sectioning of gonad tissues of Gonia discasta scabber, this is a sea star, a starfish has the high level of metachromacy found in the cells exposed to 7.6 and 7.8 pH. And there are some kind of metachromacy found in the pH 8.0, and there is an intact and good cells found in the control. So, which also indicates the cells were highly disrupted and the gonad lesions found in the low acidic conditions. So here, based on the results, I hereby summarize my results. So based on the study, we have hypothesized the level of pH in the spatio-temporal dynamic aspects, and the second aspect to study the biological effects in the microcosm exposure in the laboratory CO2 bubbling method, and simulation of ocean acidification phenomena with the CO2 gas bubbling method, and ultimately we have studied the biomineralization, biomarkers, and histopathological studies of gonads. And the physical strength and the mechanical properties of both sea urchin and the sea star were evaluated by thermogravimetric analysis, FTIR, X-ray diffraction analysis, and the scanning electron microscopy analysis. So the physiology-related biomarkers, we have also found that malondialdehyde is the highest concentration, 0.340 is found in the lowest pH concentration. And also when compared to the biomineralization, FTIR, X-ray diffraction, PGA, and same imaging images substantiate the negative impact of low pH treatments to the echinoderm for the biomineralization process. When I hereby I conclude my results. So the calcite saturation state in the Gulf of Mannar has shown most possible occurrence of ocean acidification in the region of Mandabam group of islands. And the perspective of the shell deformation, biomarker response, and the gonad tissue damage also reveal the ascertained manifestation in our results with compared between low pH exposed sample with the control animals. And this acidification level affected the both biomineral and the biomarker response, and the high level negative response was identified in the biomineral robustness. And echinoderms which have biomarkers and histopathology studies findings bear strong evidence for the physiological stress, neurotoxicity, oxidative, and xenobiotic stress has been faced by the animals in the exposure of low pH conditions. So the echinoderms have to be protected in the Gulf of Mannar region, and the studies have to be done in the aspect of acid-base changes. But not only to the echinoderms, we have to study the animals with the various taxon. Um, based on the ocean acidification research. So the IPCC prediction and the ongoing anthropogenic activity is similar pattern of high level of global CO2 emission, which is called as the business as usual scenario. The threats and effects of ocean acidification to marine flora and fauna is tedious and subtle, which need to be studied in detail by both microcosm and mesocosm experiment. So further, we hereby recommend that behalf of our Department of Marine and Coastal Studies, the large belt of Gulf of Mannar and the Indian Ocean has to be studied in the aspect of calcite saturation state as well as aragonite saturation state, because there are multiple number of reports are available for the coral bleaching. So the coral is the other case, but the effect of coral bleaching, many of us knows that it is called global warming and temperature. But the recent research explained that and exclusively reported that both pH induced response and the temperature causing the coral bleaching in the large scale. So hereby our future is dependent on the ocean. So without ocean, we did not imagine our future. So we have to strengthen the research and follow the safety methods of reducing the mitigation strategy of carbon dioxide, and which this is one of the part of the work which has to be recommended for the future policy making decisions in the regional ocean waters. So these are the presentations and publications. So far we have published in several papers, and we have recently published our whole results, physiology, biomarker, and calcification in the Cell Press journal called Helian. And these are the total journals published during my PhD tenure. And the full paper proceedings is also given here. These are the list of papers presented. And I have to thank my professor, Dr. Anand sir, who helped me a lot during my PhD tenure. And without his support, I can't imagine my PhD study. And I also thank Dr. Mary A. Sival ma'am from University of Auckland, New Zealand, who have a lot helped us for the going towards the correct measurement of ocean temperature and the replication of biomarkers, and to standardize the study. So madam suggested us very lot, and include helped for paper corrections and during our paper submission process. So thanks to Dr. Mary A. Sival ma'am from New Zealand. And I thank for the funding support from the UGC New Zealand Education Council, so which is the Indo-New Zealand project funding supporter. And next funding support is ICA or NICRO project. So I extend my acknowledgement and I extend my thanks to our chairperson, Professor Dr. C. Gobinathan sir, and our beloved professors, Dr. S. Kannan sir, Vijay Bhaskar sir, and Selvakumar sir, who helped me a lot and motivating me again and again for my during my PhD tenure. And I show my special gratitude to Dr. J. Kumar sir, who helped me with the support of ICER NICRA research project, who is the PA of the project. I give my sincere thanks to Professor Dr. E. Joy Sharma ma'am, who recognized me as a good hard worker during my MSc research, and who recommended me to do a PhD under the guidance of Dr. M. Anand sir. And I show my gratitude to Dr. S. Ravikumar sir, professor in Alapa University, and Dr. P. Sandanam sir, and Subhaya Ramaswamy sir from SBS MKU. And I am very much thankful to Dr. Andrew Dixon sir. I have an opportunity to meet Dr. Dixon sir from the Scripps Institution of Oceanography from the University of California. So when I go to the Kolkata for the international capacity building workshop, I have the opportunity to meet Dr. Dixon sir, and I got many suggestions, and he corrected me to go to the correct path of measuring the seawater coordinate system, and he find out many mistakes from my study, and he fine-tuned me. So taking the correct standardization of measurement of pH and total alkalinity values. And I am happy to thank Mr. Tavasi sir and Raman sir in our department, staffs V. Alagmalai Anna and Murugananda Bhubadi Anna, and the technician, lab technician Muruganandan Anna, who helped me at a great extent during my PhD. And I thank Mr. Sundaramurthy, boat man, for supporting for my monthly seawater collection using his FRB boat. I also thank to my seniors and my colleagues, research scholars, and my MSc students, and my dear family, relatives, and my family, who are the well-wishers and really make me to realize my progress and in research life and celebrating my success when I getting degree or awards. So I thank to my mom, Uma Devi, and dad Kannan, and brother John Agiraman, and Mr. K. Karthik Pugulendi. With their support and freedom, it is possible to accomplish my doctoral studies. So once again, thank you all for sharing me in my presentation. So.
Thank you, Mr. Rangesh.
Thank you, sir.
Dr. Das?
Yes, yeah, it is a very nice presentation.
Yes, sir.
And of course, the questions we can expect from the audience now.
Yes. Yes, the presentation is open for questions now.
Mr. Rangesh?
Yes, sir. Yes,
First
sir.
of all, excellent presentation.
Thank you very much, sir. Thank you.
Your voice modulation is very good.
Oh, thank you, sir. Thank you, sir.
Guy, Dr. M. Anand, for selecting this topic. For your research. I think Deva Roja can mute your mic so that we can clarify our doubts. Deva Roja, please mute your mic. Okay. So from your presentation, I could understand that there is no statistical difference among the physical-chemical parameters.
Yes, sir.
Seasons.
Yes, sir.
In different seasons in Gulf of Mannar.
Yes, sir. So the seasonal, based on the seasonal parameters, we have find out that monsoon and post-monsoon have the significant changes in case of calcite saturation state. For different parameters, we have find out the various changes based on the precipitation, and sometimes we have find out the blooms in Gulf of Mannar. So actually, in every month of September, in every year of September, we have find out the harmful algal blooms. I think Noctiluca blooms. We have presented our results, like some outliers found in our statistical representation. They are influenced by some Gulf harmful algal blooms in the Gulf of Mannar waters, so which significantly varies the physicochemical parameters.
Yes, I am coming to the point. That's a point you touched already.
Yes, sir.
The algal bloom, green algal bloom in
Yes, sir.
every year for the past 3 years,
Yes, sir.
and the mortality of fishes occurs.
Yes, sir.
What may be the reason whether the ocean acidification had any influence on that or not?
Sorry, sir. I think
Is there ocean acidification have influence on the algal bloom and the death of the fishes
yes, sir.
or not?
Yes, sir. Yeah, it is a very good question. Actually, 2 months before, one paper is published in the Nature Scientific Reports. So the same kind of concept. So the relationship between the harmful algal blooms and the ocean acidification. So if the harmful algal blooms is increasing in the ocean, the high photosynthesis is happen. When the high photosynthesis is happen, the more carbon dioxide is fixed in the seawater. So there is the pH changes was very high during the harmful algal blooms in Gulf of Mannar waters.
Okay. What is your suggestion for the publics after from your research?
Yes, sir. We have many take-home messages from our study. So actually, I can't find the seawater coordinate chemistry in the public websites. So I can find the temperature data or the wind pattern or current patterns in some website, but the seawater coordinate chemistry data is not available in many of the portals. So I want to suggest to some institution to include the seawater coordinate chemistry, which is ultimately in going to the future phenomena, it will be a most crucial factor for studying in common publics.
Okay, thank you.
Thank you, sir.
Mr. Rangesh, this is Marimuthu from Zoology Survey of India.
Yes, sir.
First of all, I congratulate you for your
Thank
wonderful presentation.
Thank
And
you, sir.
my small question is, how can you defend the spatial temporal word when you have selected island very close to each other? And the data also only
sir.
for 2 years.
Yes, sir. Yes, sir. Actually, we have measured the spatio-temporal dynamics in the past 5 years before. So we have a series of 7 years data. But this is when we compare between the 2015 data and the 2019 to 20 data, we can compare and we find out the reduction of calcite saturation state as well as the other associated physicochemical parameters. So our results also more valuable with the study of the previous reports.
Okay. And one more question. How much maximum percentage you got, like a standard error you are showing with some assays, no, in the laboratory assessment?
So pH or which parameter, sir?
The laboratory assessment regarding enzyme something you are telling, no, in the laboratory
Yes, sir,
assessment.
yes,
Yeah.
sir.
So maximum percentage of standard error you noted.
Yes, sir. Yes, sir. So the maximum was please admit. So the maximum standard error was plus or minus 29 in the pH, but in other parameters it will vary. So the pH standard error pH we have maintained in the laboratory microcosm as per the nominal pH. Actually, we have.
No, I'm asking about how much maximum percentage of standard error when compared to your average value. Statistically, I'm asking.
Yes, sir. We have also. I show my slide.
Rangesh,
Yes, sir.
actually, what Dr. Marimuthu is asking is
Yes,
your
sir.
number of samples. Okay,
Yes, sir.
how many samples? Then
Yes, sir.
just to say that the standard error.
Yes,
So your
sir.
mean whether it is significant or not can be easily understood by this. error. So you can pinpoint the error only,
Okay, sir.
standard error.
Yes, sir. Yes, sir. We have set the level of significance for the 0.05 percentage. We actually taken the data sets, 288 samples we have collected from the Gulf of Mannar for 2 years. Is it clear, sir? Or
Okay, proceed for
No,
other.
actually, Rangesh sir is asking about at the each time, suppose if you're going for one sampling, how many samples you collected at
Yes,
one
sir. Yes, sir.
site?
For one site, we have collected the 9 samples. So we have triplicated the samples for going when we going the morning samples. We have collected 3 samples from each depth. So surface, bottom, and the middle depth. And for triplication, we have collected the 3 times. So totally 9 samples for one sample.
What Bharat ask is, you just put mean after plus or minus some value.
Some
Okay.
values will be there, no? Like,
What is that value? That is what asking. So
Yes, sir.
with that value, we can generalize, or it is a random one. We can know is.
Yes, sir. Actually, this is a random sampling. Our actually pH value is plus or minus 1 to, sir. So in a laboratory-based microcosm, it going to plus or minus 29, sir.
okay, thank you, Rangesh.
Thank you, sir.
Rangesh,
Yes,
Yes, sir.
yes, I have a few clarifications.
Yes, sir. Yes, sir.
In the beginning, carbonic acid will be formed
Yes, sir.
and it disassociates into carbonate and bicarbonates,
Yes, sir.
leaving free hydrogens.
Yes, sir.
Is there any possibility to these free hydrogen again combine with carbonate to form bicarbonates?
Yes, sir. Yes, sir. So actually, the last step is the accumulation of hydrogen is associated with the naturally occurring carbonate. So hence, the bicarbonate is accumulating in the ocean due to the ocean acidification chemical reactions. So consequently, the bicarbonate ion concentration is increasing, whereas the carbonate ion is depleting, sir.
Decreasing.
Yes, sir. Yes, sir. Depleting.
Yes, sir. And also, when you are talking something about the toxic bloom,
Yes, sir.
have you come across specific algal species which causes toxic bloom in Gulf of Mannar region?
Yes, sir. In the Gulf of Mannar region, we have find out one harmful bloom algae that is called Noctiluca scintillans, sir.
Noctiluca.
Yes, sir. Noctiluca, sir.
Yes.
Thank you, sir.
Thank you. Thank you, Rangesh. You presented in an excellent way. Very good.
Thank you, sir. Thank you. Sir.
Rangesh, in your concluding remark, you just said a word.
Sorry,
It
sir.
is in your concluding remarks,
Yes,
the
sir.
conclusion slide, you have
Yes,
said
sir.
that in a recent finding,
Yes, sir.
coral bleaching is exclusively because of pH. How can you substantiate this statement?
Sorry, sir. I did not understand.
See, in your concluding part,
Yes, sir.
you have said in a recent study,
Yes,
it
sir.
was confirmed that pH is the exclusive reason for coral bleaching.
No, not like, sir. Not like,
Ah.
sir. This is an associate part. The temperature is a primary part, and the pH also making the coral bleaching, sir. So not exclusively, sir.
Okay. And regarding, do you think is it possible for giving data for the seawater carbonate for region wise all
Sorry,
over the? Is it possible for displaying the
Yes,
seawater carbonate values for the entire coastal area?
From my slide, sir.
Not my your side. You just give a recommendation. Is it possible?
Yes, sir. Yes, sir. Coordinate data is possible, sir. We can done the titration methods, and some potentiometric titration methods are available, sir. So the automated system is available.
Because most of the data is what we are using is modeling data. Okay.
Yes, sir.
For example, last week I was at Mandapam,
Yes, sir.
and at this temperature, without the temperature is very minimal, and everything is normal condition. But we saw some blooms, and the water is very foul. but the temperature and everything is normal.
Oh,
Okay. So in this situation, how would you interpret that this may due to some other ocean acidification or carbon dioxide related?
yes, sir. In that case, that is what I told you before, sir. The outliers in our statistical results found that the error value we found during the bloom, because other parameters is also reducing. The DO is also reducing, so this will also influencing the other coordinate parameters.
So by outliers, what do you mean? What are the parameters sitting in the outliers?
Yes, sir. So the outliers, we actually limit our seawater coordinate chemistry data like carbonate, bicarbonate, PCO2, FCO2, and the total carbon dioxide and the Rayleigh factors. So the Rayleigh factors. Apart from that, the external parameters, we can say these will be the errors. The external parameters, we can mention it, sir.
Okay.
Thank you, sir.
You have done excellent work. Okay.
Thank you, sir.
I congratulate you.
Thank you, sir.
And Anand. Okay.
Any other questions?
Rangesh,
Sir,
Rangesh,
sir,
this is Santanam from Bharatdas University.
good morning, sir.
Sorry, I'm not able to join because
No
I
problem.
had a class. But last week I joined. I know you did an excellent work because I personally visited your lab, Madam, when we are doing experiment. Really, it is very tough job by mimicking the acidification experiment itself is very challenging.
Correct.
Because I know very well personally, Dr. Anand sir and you struggled like anything during the initial time to create this experimental setup for ocean acidification experiment. I don't have any worries and all because I know your work, you did excellent work under the guidance of Dr. Anand sir. I want to record my appreciation and congratulations to you and Anand sir for a nice piece of work. I think to my knowledge, very few people are working on this aspect, acidification. The reason why the people they are not showing the interest, creating the facility for experiment of acidification itself is very challenging. So that the people they don't want to work on this aspect. Even with this barrier, you did excellent work. I personally visited your facility, and he stayed there at Madam as like a place like Parangipete where we did our PhD. I know very well personally. My congratulations and my advice: you just publish your data, whatever data you generated from this work.
Yes, sir.
You can try to publish in a good journal as early as possible because this is interest among the environmental scientists, especially marine scientists.
Sure, sir. Now we are trying to communicate.
India is concerned, very few articles, published articles are there in the ocean acidification statistic. So my advice, you should publish as early as possible so that you can get good opportunity. You can apply for some PDF also in the same topic with some other organisms, calcified organisms.
Okay, sir.
So my congratulations to both you and your guide.
Thank you, sir. Thank you very much.
Nice piece of work, and as Sir mentioned, Rai Kumar sir mentioned, you presented well your modulation, voice modulation and all. Really you developed well. My congratulations and appreciation.
Thank you,
With
sir.
regards
Thank
to
you.
all my seniors, colleagues, and the examiner, Dr. Das, Kumar sir, and Rai Kumar sir, and all my seniors and well-wishers, those who joined for this YOC examination. Thank you, sir. Congratulations, sir.
Thank you.
Congratulations.
Thank you, Sandanam. Thank you so much for your kind words. Thank you so much.
Thank you, sir.
So, any other questions, Dr. Das?
Well, I have gone through the thesis and the questions I have marked in my report. I hope
Dr. Dinesh wants to ask one question.
Yes, sir.
Yeah.
Dr. Das, Dr. Dinesh Ram sir is there in the line. He wanted to ask some questions.
Yeah, sure. Dr. Dinesh, please.
Yes. Hi, Rangesh. It was an excellent presentation. This is Dr. Dinesh from CSIR National Institute of Oceanography.
Good morning, sir.
Yeah, it's a wonderful topic. It's good to know that I think people from southern India, especially located in Gulf of Mannar, started working on ocean acidification. I think it's the first kind of study.
Yes, sir.
Usually in India, we are working only on most of the aspects with biogeochemistry. So it's a good thing to know that you had started working on animal response with respect to ocean acidification.
Yes, sir.
And it's also good to see Mary here. Hi, Mary.
Yes, sir.
Yeah, I have few clarifications
Yes.
with respect to your levels you had chosen for pH.
Yes,
The
sir.
first thing is, I think you had measured some biogeochemistry parameters with respect to Gulf of Mannar Mandalay.
Yes, sir.
So you had shown that pH level was around 7.8 to 8.5. So I
Yes, sir.
don't mean that there is a chance of pH to go exceed beyond 8.2 or 8.1
Yes, sir.
at any cases. So what was the reason that you had measured 8.5, especially
Yes,
in the Gulf of Mannar region? Because we are also doing some measurements over there. And
No, sir. No, sir.
if you can go back to your slide, biochemistry slide, it would be nice.
Yes, sir. Yes, sir. I can go back to slide. Sir, this is the slide. The pH level actually varies from.
Can you share it, please?
Yes, sir. Yes, sir. I will share it. Sir.
It's already shared.
Yes,
Yes.
sir.
Yeah, so just I want few clarifications over here. So first thing is salinity. So salinity is about 7.8, which is acceptable. Maybe in the presence of monsoon, maybe it may go down, but the highest level you had shown is 8.5, which is not practically possible. So
Yes,
just want to clarify a few things, whether you had followed this Dixon protocol. As you said, you had been mentored by Dr. Dixon as well. So
yes,
whether have you used standard seawater for your intercalibration whenever you are performing seawater carbonate chemistry?
Yes, sir. Yes, sir. So actually, we have followed the standard kit from Merck et al. I have also got suggestion from Dixon sir about my measurement. When I show the presentation in front of Dixon sir, he also told that this is possible of some errors in your instrumentations or measurements.
Yeah. So
Actually, yeah, yes, sir. But actually, after his advice, I did my experiment with a 3-scale calibration system. But there also we have the measurement. When we measure the pH in the morning and compared to the evening, the variation is more found. And when the seasonal basis, the pH level is varying. So after the calibration point, we have we can see the ambient pH in most of the times, and in sometimes the same pH calibration. The calibration error was not found, but the pH was vary up to 8.55. When I checked with the reports in the Springer journal authored from Armugam et al., whose results also happened like 7.9 to 8.5. So there is many aquafarming in that regions we can saw, and in that region our MSc dissertation students also measured in that region. So in that region, the pH scales, the pH ion, the accuracy of pH measurement was 0.001 resolution. So in that case also, with the fresh Merck calibration solution, we can record a 8.55 in the some case in the post-monsoon and monsoon seasons.
have you ever performed measuring dissolved inorganic carbon in your first part of your study, especially
Yes,
for
no, sir. We actually did not measure the DIC. Actually, we have measured the total alkalinity value using the APHA measurements.
Yeah, I could see that in your table. So most of your data is tabulated based on pH, salinity, and total alkalinity. So
Yes,
because the values you show for partial carbon dioxide pressure is also a bit lower, which is 36, and the maximum you show is 385. So for 8.5 pH and with respect to salinity 35, I don't see there is a possibility of 385 because you also recorded temperature to be maximum of 37 to 38. So at high degree of temperature, there is no dissolution rate of carbon dioxide in water is quite low. So that also you need to see over here. And the value you are recorded to show here is 36 for partial carbon dioxide pressure. So that also you need to recheck these values to see whether it is appropriate to show.
That is we derived from CO2 cal software.
Yeah, so based on your physicochemical parameters like the carbonate chemistry of a calcite aragonite, why you didn't show the aragonite values? I'm not sure why you had omitted to show those values in your table. I think you should also include your aragonite saturation state as well.
Yes, so we have also have the data, but we thought that the data of calcite, which indicates the health of echinoderms. So my senior results, who done the PhD work on aragonite saturation state, who study the health of mollusk which has the aragonite based shells. So who provided the aragonite saturation state, and I preferred only to include a calcite saturation state.
Yeah. So my little bit of concern here is like since Mandapam area doesn't have any industrialization happening out, so there is no chance of like carbon dioxide coming down to 7.86 or to the future levels what you had chosen 7.6. So that you may able to justify. Then one more thing, like can you go to the next slide showing echinoderm?
Okay, sir.
So you had chosen 4 levels of pH levels. So one is 8.2 and 8.
Yes,
and the other one was 7.6 and 7.8. So on what basis you had chosen these values? And
Yes,
especially this 7.6, what does it represent as per the IPCC scenarios?
Yes, sir. In the IPCC scenario, they pointed out with some reference in that continental shelf region, the 7.6 is there. So actually, in some depths, in the depth of continental shelf, the echinoderm possible to live in that region. So that's why we choose the 7.6 pH in our study. So I show you my slides in the. So this is the scenario. Here the lowest aragonite saturation state observed in the near bottom waters of the continental shelf with a close pH value of 7.6.
So is that with respect to the Indian Ocean?
Not sir.
Yeah, so I think when you are fixing up your values in future, no, because we also do the same ocean acidification experiment. So we have these queries always coming up. So on what basis we had chosen the pH levels? So that has to be justified before choosing the experimental parameters.
Okay, sir. Sure.
Okay, then can you go to the total protein concentrations plots we had shown?
Yes, sir.
So your experimental design is so good. Really appreciate your efforts. You had put up a lot of effort to carry out your experiment.
Thank you.
Yeah, this is the one. So here you are trying to show there is a decrease in trend of total protein. So
yes, sir.
So if you see the plot, especially with the control 8.2, you have chosen here 8.2 as a control, which is 0.4 milligram per gram.
Yes, sir.
And whereas your pH, lowest pH you have chosen is 7.6. It is almost more than half of it.
Yes,
or
sir.
only 1/3 of it you are just trying to find out in 7.6. So how can you able to justify this concentration here?
Sir, so actually we did triplicate samples. When we compare with the spectroscope measurements, we think the same data used for the acetylcholine esterase concentration. So when we compare with the all biomarkers, so the decreasing pattern of catalate and acetylcholine esterase also going to the depletion, and we predict that this depletion of other enzymes may be the reason for reducing the total protein concentration.
No, like what I feel is like since the protein concentration is quite low, it looks like the pH levels you had chosen is totally highly toxic for your organisms. So in that case, if protein concentration is less over here, Then if you have to see the other parameters you have chosen for other enzymes, so it should be proportionately to be higher in the same level. But if you see your data, I don't think there is a proportionate levels of increase in the concentration.
Yes, sir. Yes, sir.
So only I think you have to look into your protein level. So maybe which is not proper over here. But whereas I could satisfy with your other pH treatment levels, because there is a significant trend, but the trend should not be much more than what we expect from the protein concentration level. So
Okay.
those things you have to look into. So overall, I think your topic is good. The way you selected, you have tried to show up your PhD with a multidisciplinary approach, where you have taken a lot of efforts to talk about physiology, biomineralization, and also you had included biogeochemistry as well. I think it's a wonderful move from your side. Good luck with your presentation. Yeah.
Thank you, sir.
That's it from my side. Yeah, thank you.
Thank you, Dr. Dinesh. This is Anand here.
Yes, Dr. Anand.
Yeah, actually, I would like to address 2 points about your query. So the first thing is you asked about the Gulf of Mannar is so pristine. The pH levels may not go that level as cannot compare to Tuticorin. The industrial activities is not there. I accept that, but from our experience, what we found that the pH level variation is there. Subject to its, in the recent years, the pilgrim tourism has increased, and well-laid road has given an opportunity for improving the pilgrimage tourism. That is the vehicle emission to be checked in the Gulf of Mannar area. And added to this, a lot of trawler operations also adding some CO2 emission in that area. So both Park Bay and Gulf of Mannar side. So I mean, this is maybe a theory, but we need to work on it. How these emissions are having influence on Gulf of Mannar area. That is the one thing. Thanks for this work, opening this question. And another point is regarding the standardization for selecting the pH level, the maximum and the minimum, as you asked. This is still we need to standardize that. Of course, I accept that. We need a lot of wild observation data from our Indian Ocean coast, and then I think we can come out with clear picture about what is that scenario of ocean acidification level in Indian waters. So I think in these two areas we need to have more work to be addressed in wild environment.
Yeah. Thanks for the clarification, Dr. Anand. I think Mary is having some.
Yeah. She's waiting online. Mary.
I was just hi Dinesh. I know Dinesh from our time in Hong Kong, but just wanted to clarify that the pH can get to 8.35 and 8.4 in other parts of the world. For example, in Antarctica, in the summer, when you have large phytoplankton blooms and a large drawdown of and changes in the DIC, the pH can go up very, very high. So I think that it is possible. It's not very common. It's going to be in unique situations, and perhaps southern India is one of those situations where you can get extremely high pHs. So that was just a comment. Very nice presentation, Rangesha. It's a huge amount of work you've done there, and you should be very proud of yourself. Great presentation.
Thank you, Dr. Mary.
Thank you.
Yeah. Thanks, Mary. I think I would like to add a few things here. I think it was a good suggestion. I think we have to look into these pH levels, since there was more of algal blooms reported recently in Gulf of Mannar. Maybe that might be an impact to raise out these pH levels. I think there are a lot of programs coming over. I think people should also participate, because we also do, and we are actually work based on the satellite data. So, but there is no pH data collected.
Okay.
So for long term, especially like in this study, which has been done for more than a year, I guess. So this type of data is highly required for modeling what is going to happen in the future, climate change scenarios, especially with respect to pH. I think people should continue this work, and we'll see how we're able to just improvise in future.
Thank you, sir.
Yes,
Thank you,
sure.
sir. Definitely we will
Thank you so much. Thank you for
Thank you. Thank you.
now, Dr. Das.
Yeah, there is one more query from Dr. Umadevi Kannan.
Yeah. Thus, before going for our next question, shall I ask the question of another examiner, Dr. Palavesam, who has raised 3 questions?
Yes, yes, please carry on.
Yeah. Mr. Rangesh?
Yes, sir.
Another examiner, Dr. Palavesam, has asked 3 questions. One
Yes,
is
sir.
justify with reason for fixing the lower limit of pH 7.6.
Yaru Umadevi Kannan.
Yeah, that is what you already answered.
Yes, sir.
For,
Yes, sir.
the
I already answered. Yes.
And the second question is explain the relation between carbonate parameters recorded and the calcite saturation state.
So actually, the carbonate is the important essential parameter to combine with the calcium ions, which will form the calcium carbonate. When we see the principle of saturation state, the saturation state is when we see the precipitation and dissolution aspect. When we see the precipitation, the calcium and carbonate level is binding. The chemical reaction is more in the case of precipitation, and the very low concentration in the case of dissolution. So there is a very close relationship between the carbonate and the calcite saturation state. I already show you the slide. The 0.853 is the correlation value. There is the strong positive correlation with the carbonate with the calcite saturation state. Thank you, sir.
Okay. And the one more question is how did you use this software to predicting the pH and the research design? I think you already mentioned.
Yes, sir. I already show you that the C-Corp package, the OR software's C-Corp package, we can go for the some software packages can predict the future predicted pH using the predicted carbon dioxide emissions. So if we put enter some parameters, the algorithm actually captured that parameters and it will show so what the parameters in the future scenarios. Say like in 2100, when we predict the CO2 business as usual scenario emission, if the CO2 going to 800 ppm, so the algorithm actually calculate the other constant in the seawater carbonate chemistry, and it will show the remaining parameters. Yes, sir. This is the concept that prediction of pH has been done. Thank you.
That's fine. And now over to Dr. Das.
Well, so I have raised a couple of questions here, chapter wise. Do I need to ask, or he has already amended these in the cases?
Yeah, he has already given explanations for these, and we submitted to our authorities. And if you have any questions further in this presentation, you can post.
Fine. I'm okay with that. The questions which I have raised are fine, and based on the discussions here and the questions from different experts, I'm really satisfied, and I have no more questions from my end.
Yes, thus. So you can conclude.
Okay, so if audience, I think there is still Umadevi raising the hand. Okay, she is not here perhaps. So if no more question left, and based on the presentation and the high quality work, I recommend Mr. Rangesh to Madurai Kamaraj University for the degree of award of PhD in marine biology.
Thank you very much, sir.
Thank you so much. Thank you so much.
I congratulate Rangesh as well as Dr. Anand for writing and producing such a high quality work on ocean acidification.
Thank you so much. Thank you, Dr. Das, for being with us as examining the candidate and conducting this Viva examination. And thank you so much for your sparing your time. I know you have such held up in conducting the examination of your academic task and you are sparing your time. Thank you so much. Thank you so much, Dr. Das.
Thank you.
I thank Dr. Mary. Even being is a late evening over there, you are with us, and it's nice opportunity to meet you after a long time. Thank you so much. And I express my thanks to Dr. Ravi Kumar sir, Dr. Jay Kumar sir, Dr. Sandhanam, Dr. Pradeeshwaran, and of course Dr. Sellu Kumar sir, who is always encouraging the candidate since his PhD thesis. Our chairperson, Dr. Gopinathan sir, Dr. Kannan sir, Dr. Vijay Bhaskar. So such a support from all friends and faculties and colleagues, we could able to complete this work possibly. So thank you so much for all of you for being with us and successfully completing this 5 hours examination of Dr. Rangesh. Now, Dr. Rangesh.
Thank you very much, sir.
Thank you.
Thank you, Mary ma'am, for your clarification during my paper publications. Thank you, ma'am. Thank you, Dr. Jaykumar sir, for your help in my PhD tenure. Thank you, sir. Thank you, Wilson sir. Thank you, Panchacharam sir, and Rama Ranna, and, who makes me encouraging in various times in my PhD tenure. So,
Rangesh, congratulations, Rangesh.
Congratulations, Rangesh. It is a great moment. You enjoy your day today.
Thank you, sir.
Last, happy to see you after a long time.
Okay. Yes, sir. Yeah.
So soon come to Madurai. Okay.
Sure.
Thank you.
Yeah, Dr. Das, now situation is getting comfortable, so you can make
no problem. We will be visiting soon.
Yeah, and Dr. Mary, you have any plans to India? How is the situation there?
Yeah, sure. We will talk later on this.
Yeah, please.
Surely we can.
You can. You can sign off.
Yeah, sure.
Yeah.
Congratulations, Dr. Rangesh.
Thank you, sir. Thank you, sir.
Congratulations, Dr. Alan, for excellent work and was.
Thank you, sir. Thank you, Panchacham.
And selected in ICNET Dams. Okay, it's an excellent presentation, and I enjoyed this presentation.
Thank you.
Thank you.
Thank you, sir. Thank you.
So, friends, I'll sign off the call. So, thank you so much for joining with us. Thank you so much.
Always save.